Hey everyone, and very good evening to all. Today's our event title is How Gemma Introduced and Fine Tuning. Here, this is SAJJAD. Um, so, today's tentative topics I am going to cover that Gemma introduction, backbone of Gemma, and the transformer model, what it is and how it helps to build gemma, and then fine tune code, and also uh, how works on Vertex AI. So, well, let's start from gemma, what it is. uh, well Gemma is a family of lightweight open model that built from the same researchers team that built Gemini model, and we all know that the Gemini family has three version, and the Gemini model work with uh, multi media, like multiple model. It can generate text to image, image to text, and so on, video, audio. But here in the Gemma, it is the uh, specifically work for LLM. So the same researchers team developed gemma 2, and initially gemma trained up 6 trillion token of text using the similar architecture of that use gemini. And we can see that gemma right now gemma has two version. One is 7 billion parameter, and the second one is 2 billion parameter. So the question is rise in our mind that why the two version are available right now. Well, uh, the 7 billion is efficient and development for gpu and tpu, as we have from as a end user, we have sometimes we do not have gpu or tpu. So for this our case consideration, probably they will develop the 2 billion parameter, and that's efficient for cpu. So why the size is different? I already mentioned that the size different, and it's also different for computational constraint, application, and developer requirement. So if we do not have the number of gpu or tpu, so how can we run this model? We definitely use the 2 billion parameters gemini. And also we can see that there is a bar chart that I collect from the technical report. So what does it means? Well, uh, right now there are many open LLMs model available, we all know. So among them, they compared 18 benchmarks. Among them, Gemma performed 11 out of 18. That's a remarkable sign. And here in this picture, it denotes that they consider the four key point of academic. These are question answering, common sense reasoning, math, science, and coding. So we can see that compared to the LLM2, LLM13, and Mistral, among them, the Gamma 7 billion outperform well. So, and nearly Mistral in the coding, especially, and the math and science, where Gamma outperform than any other open model. So, how do we access Gamma today? Well, there are several way we can access or run the gamma model. First one is we can famous our kaggle site, and then bartex ai, where model guardian will show later. And our the model collection hub is hugging face, none other than. So anyone what we can choose. Also we can run this gamma in our Google Colab too. So, how Gamma built? Well, as I told you that Gemma built based on Gemini. So the question also arises in that how Gemini also built, or is this the model overnight? Last 2 years, from last 2 years, we see that every day there are developed new model, but that is not developed overnight. They come through a process. uh, First they start from the sequence model, and then we saw the before the generative uh, GPT introduced, the deep learning perform well and it used everywhere. And the transformer also, gamma built based on some before gamma Google have some open models like word to vector, BART model, and T5, also T5 series. So uh, among them, the key point is that transformer revolutionize everything. So I will also describe about the transformer. So before moving on, we want to show the gamma architecture. If we follow this picture here, we can see that the encoder and decoder. This is from the, we can say, the transformer architecture. But here, uh, well, the Gemma architecture is depend on the decoder of transformer that only, if I annotate this, they just based on this. And the transformer is both encoder and decoder. So only the Gemma has the decoder part, and we can see the parameters. So the dimension of the model, it represent whenever we took and represent by the vector. So in the 2 billion param, the vector size is 2048, and we can see that the number 3072 dimension for 7 billion model. So as we fine tune with uh, gamma 2 billion instruction model, so we focus on that. uh, Also, we can see that the layers of the model, a layer means that how many number of this decoder. So there is the 18, and 7 billion parameter model has 28 param. And the interesting things is that we see that the head size both are similar and the vocabulary size both models are similar. But number of kv means key and value for head. In the Gemma 2 billion, it has 1, and the 16 for 7 billion model. So the number of kb head more gets the more efficient result. So definitely, that's why Gamma 7 billion perform well than 2 billion. So as I earlier told you that the Gemma is an open model based on others, like we saw that Transformer, BART, T5. So what make the Gemma specialty? So, well, the I find from this three key point from the Gemma architecture, Gemma technical report. These are loop embedding and GZLU activation and RMS norm. So the these three things make the Gemma architecture stronger than other model. Well, so I mentioned it several times about the transformer. So what is transformer? Uh, well, just according to the name, whenever transformer is a model where we can give input in one way and find output in the other language. It can change the input to the output. Uh, okay, I have take to 2-minute break as the noise in AI. Okay, I am talking about the transformer. So why I mentioned this word several times that transformer. Well, uh, before we moving the describe the architecture for better understanding, I just the give brief introduction that when transformer, just imagine a black box. We give input and instruction, then it convert easily another word. Look at this example. We just you are welcome, and we pass this text in the transformer model and told them that convert it into the Paris. So de nada. So moving on, the I titled the chain of Gemma means that how actually Gemma build, or how today's the LLM model build actually. Well, this is the tentative outline. I just created this for simple understanding. First of all, the ML, basic ML is exist, and with this ML we can easily classify that the text is spam or other, not spam email. But and then later on the multi-layer NN, we can also that the subset of, we can so the deep learning here. Among the deep learning, before the transformer arrive, the RNN model and is one of version is LSTM. Both perform well. They can generate very short sentence, like if the sentence has 3 to 4 words, they perform well. But whenever the sentence goes too longer, they do not perform well. So how to solve this problem? So now we had the one term is that Gen I or GPT. So how do you build? So after the DL, in 2017, Google developed a model and proposed the paper that attention is all you, where the transformer born, and based on the transformer, the generative AI build, GPT model build, and so many things. And another, the real example of transformer is BART, that is developed by Google. It's obviously arrived before Gemma. So here I can see that two word, that LLM and LIM. Well, the generative AI, we know that it can generate new context or new thing. So LLM means a large language model, and LLM large image model. So it has two part basically. So for the text to text work, we just use LLM, and if we use to image related work, we use LIM model. So our Gemma model is LLM, and Gemini is both LLM plus LIM is a multimedia model. And then after the this transformer revolution, we find that Gemini and then Gemma. So this is the actually real backstory of the how the today's Gemma built. And we can see that the clear revolution start from the transformer. So the transformer, before the transformer, the DL work sequence to sequence, which means that one word after one word, as it's required more time for computational. And in the transformer, it works parallel. We can pass at a time a sentence, where uh, a sentence we can part word by word in the RNA. So, what is the architecture of transformer? Well, this is the uh, architecture of the transformer, where we can see encoder part in the encode and decoder part for the output. So, in the encoder part, we will also clear version later. So, oh, and one thing is that all the encoder part are identically from the e- each other. So uh, and if we clearly show the which of what is the inside of the encoder part, well, we can see that each encoder, it has two parts, self attention and feed forward. and in the decoder part, both terms similar, but it additional has encoder and decoder attention. So we can introduce other word, attention. What is attention or how it attention? Well, basically the transformer model work well because of the attention. So what is attention? In general, we means that whenever wisdom of crowd, for example, many people together, and all are wearing white and black dress, but someone wearing red dress, just take it for example. So all are focused whenever he uh, come to the stage, so all are focusing, all are give her attention. So as like in our the word, so what will the next word after we type two word, we can see in our smartphone that it can predict some word like I am, and then the letter word automatically the AI show find. So this is the attention, that what attention means, which next word give the first priority. So here we can see an example is that the boy is holding a blue ball. So we can see that the blue refers the ball has at the similar connection. Attention is the blue, blue indicate the ball, and also the holding indicate also ball, but not ball indicate the we can see that the boy is blue. No, the ball holding is a blue ball. So we see that there is the less line between the connection of blue and boy. So this is the attention, and the attention is the groundbreaking performance of transformer. So we can see also two example like this: the cat drink the milk because it was hungry. uh, the question is like that, where what the at refers. So this is the sentence, and it passed through the token in the transformer model, and then it so our target is to find what does the it refers. As a human we can easily say that it refers the cat, but how do the model actually understand? Well, it can compare with just for simple understanding, it just compare score with others word, that which one is more close. We can see that the it also refers itself, but here we can see there is a deep line between it and cat. So we can see that the it refers the cat. Similarly, on the second example, if we follow that the cat drink the milk because it was sweet. So where what does the it refer? Well, uh, in the how the attention actually works. Just before example, we see that it refers the cat, and the second example it refers there is a deep line between it and milk. So this is the way the after the transformer, each word has an individual's score, and then it denote like the which the one has more attention score, it's predict this one. Well, so I so many things about the transformer, but here is the pictorial view of the transformer inference flow. I just quick overview about this. Like uh, first of all, we just the first sentence is our example. We pass this in this divided into token, and each token convert into the embedding and position embedding, and then pass through the encoder, and then after the encoder it uh, also pass a encoder vectors, and this also start from the decoder, and here decoder to decoder attention, then finally linear softmax, and finally output. And at a time it works a single word, and then it repeat until the sentence end. Well, so as we mentioned it, that the attention is the groundbreaking of transformers. So in the transformer there are three attention. in the encoder has one attention, and in the decoder has two attention. One is itself decoder attention, and another is encoder and decoder attention. uh, okay, so how decoder attention work? Well, inside it has three vector like value, key, and query. So whenever we pass a embedding and sequence vector, it split it into three way, and then after passing through this this vector encoder vector with the what I say, then pass through the self attention and then encoder decoder attention. So uh, what makes the transformer most workable is depend on it the today's LLM model work well. So this is one of the way is multiple head attention. So whenever we pass a competition a word vector, it can split into number of n way, and then each has individually query, key, value, and after it pass through a separated head, then it combined with a mask, and finally then return the result. So well, as I also already mentioned that the rope embedding and the G GLO activation. So these two terms make the today's Gemma unique than others open model. In the transformer, we just see that the embedding they use. So in the root embedding, which means that root rate position embedding. In the general embedding, positional embedding is just give a like consider a vector return, but here in the rotary position embedding, it consider a uh, what I say rooted with a point. So if we clear understand, if we follow the picture, then you can see that here is the angle exist. And why they use jello activation? So well, we know that what's the activation function work in the neural network. Well, whenever the weight pass through the neuron, the we know that each neuron has two part. One is that it has the previous output, and others throw past the activation, then the next neuron input. So if the neuron, just simply to say if the neuron is active or not, it depend on the activation function. So we know that the ReLU and sigmoid is the very common activation function in our neural network or deep learning. But here in the gemma they use GLU activation, that is the combination of GLU and GLU activation. And this is the trade off between computational efficiency and model performance. So if we, whenever we consider these two things, that our model has the both performance and the computational efficiency, then we use it. And exactly the gemma use this activation. So this all about today's theoretical presentation. Now I want to show moving on the coding part. Uh, let's open. Let me time the open the code. Okay. Well, so okay, it's take few minutes. Okay. So here in the second part of today's topic is that I use Gemini 2 billion model and its instruction uh, 2b-it. We know that already Gemma has typically four version. 2 billion, it has both based and instruction version, and 7 billion. So I used here 2b instruction version for this code. So I am not running here. I just described what happening as I ran this code few minutes ago because of the device computational, and sometimes it take few times. So let's start. First of all, we must install this desired library, and where we show that bits and byte install, because as the we know that Gemma 2 billion model is approximately trained by 2 trillion text and token, so we cannot download the full model in our local, so we have to quantize it. So here is the another term, quantization. uh, so quantize, just simply to say that we have a big model, we just reduce the size and then fit our end devices. uh, Also, we use PFT, which means that parameter efficient, and we know that the weight are generally set up as a floating point, and each floating point it has 32 bit, and in the 2 billion parameter, you can imagine how much its GPU or TPU need, as we are using local and devices free collab, they just give us 15 GB RAM only, so it's not possible without quantization to run the or fine tuning the model. uh, we can also use the transformer is a library where we can find all the NLP related or LLMs model, and from here we can also import the necessary model like bit byte configuration and Gemma tokenizer, as the tokenizers are different from model to model. So where I can just as I am download it from the Hugging Face, so I just put this the Gemma 2 billion IT as a model IT. How do you find? If I just copy the name and search on the search engine, we can return the Hugging Face, the model. So where actually the Google released that open model of Gemma 2b, and we can configure download as 4-bit. We know that there are I told that initially the weight of the parameters are stored in matrix as a floating point 32 bits. So when we quantize, we can reduce it half precision, means that floating point 16, or we can convert it into 4-bit or 8-bit. Here I am using 4-bit, and yeah, so as a output generate, so I just pass the 20 max token, we can set it 150 whatever we want, and in the print output I just skip special token true, which means that each model, like if I visit here, okay, so you can see that the starting the output is like the VOS and angle bracket, and the end, each sentence has a end of turn. So sometimes the user get confused, so whenever we speak the true, it skip this special character. And where we use LoRa config. So why we use LoRa config is one of the method of parameter efficient. It works with the rank matrix. Based on the rank matrix, I will also show a mathematical intuition later after end of this code demonstration. And I load the dataset, also the dataset from the Kaggle. So basically, what about I want to do fine tuning. So why I need the fine tune? Well, consider this is the model ocean, like 2 billion parameter. I do not need all the param or all the information. Like if we were using the fine tune, we can develop different model. For example, if it has a finance, they can develop a finance chatbot. If the medical assistant need, they just want to medical. So we just also say that through the fine tune, we just domain specific create the chatbot. So that's why the fine tune arised, and we can develop whatever we want to do from this. And so in this data set, there are a lot of data set available. We can fine tune anything that what we want actually. So in this data set, it has two two feature as a train and one is as a output. So if I give the question and context, it return the answer. So I load this data set here and mapping it, and then I just the formatting how I want to see the answer in context. And here I use SFT as a trainer. SFT means supervised. Why it's supervised? Like we give that the model that question, answer, and context. So we can say that it is the level and this is the feature. So we train this supervised. And if we I just said the max step 20 means the epoch. So in the fine tuning, so what can we do? We can change or set any value from here, depend on what we want, and depend on this we can perform, or we can make the model better. So I just for the reduce the time, I just set the max epoch is 20. And so here we can see the train, we can see over the iterate it lost the training loss. And this is the actually goal of any trainer or any uh, ml developer. What I say, when we train, we always want to reduce the loss over the time. So now it's time to pass text and context. So question and context. So I passed it here, and this is the that model replay to me. Like so, this all about our fine tuning code here to be instruction. So I also mentioned one thing about that LoRa config. So how actually it works? Well, I draw a mathematic. mm, well, initially we know that just consider a 3 into 3 matrix. So this is the our like the parameter here, 4 5 6, like a random number. So this is the our weight matrix. So in the LoRa config, what it can do, we can see that the del of weight equal to initial W plus A into B. So what do they do actually? So they similarly they decompose the matrix. Okay, so decompose like this way, like this is the 3 into 3 matrix. So it can convert it into, okay, this one first one should be column and second one should be row. Column matrix, we know that the size of the matrix is, and this is the, okay. So every time how do you find the rank of a matrix? We all know that the basic math intuition, or we can just call the numpy default library. It can easily, whenever we pass a matrix, it can easily told us the rank. So oh, my bad, what I am doing here. So in the LoRa, the specific features is the matrix decomposition. So matrix decomposition, it decompose or part the matrix into two way. One is the column and another is the row. Individually, when we know that whenever we multiply these two matrix, we know that how to matrix multiply. If the first one column number is similar to the second matrix row, then multiply is possible. So whenever we multiply, we can get 3 into 3 matrix. So the way we can reduce the weight. So this is the great feature of the LoRa, and the way it can reduce the model weight. And consider this A and this B. So well, that's all about the LoRa configuration that we using here, like where I am using it. You can see that there the LoRa, actually we can pass any number value, any integer here from 1 to 50, anything that we can pass here. Okay, maybe this. uh, Also, now I would like to talk something about the Vertex AI. What is the Vertex AI? Well, the Vertex AI is the platform of Google Cloud. We it, it here, if we visited this first one, this the dashboard we first saw, we can deploy easily any model from here, or we want to train custom. I just use the Vertex AI Colab Enterprise similarly for the same code that I used in my local Colab. So there is not I can see the uh, magical difference between this, as I train a small data set and using, but it can gives the more efficient way to run. So this is the same way. So how, where I find in the Colab option, we can find a notebook and the Colab Enterprise. uh, Anyone saying anything else? Hello. uh, okay. So in the Google Vertex AI, if we visit to the model garden, so we can see that here the different type of model. As today's topic is gemma-2b, so it takes sometimes to load with. So we can see that if we click here, the specifically gemma. So I face an error whenever I want to click one deploy. It often shows me that I have accessed the code. So I'm sorry to say that I cannot display the thing, like if I were pass a prompt like what is transformer. So I saw the many articles and video. If we pass through here, it must be returned, and the text as a answer, but it cannot show me. It always open show the error that I exceeded the quota. That's why I do not deploy. If we want to, excuse me. So in the earlier we saw that if you want to open notebook, just click here, it can shows which type of notebook we want to open. There are, we can show the 4 version, and if you are have idea about the Google Kubernetes serving, you go from this. If you have just uh, just want to normal running, you can choose the number 2 or 5. uh, but if you want to deploy one click, you just click here, and it can we can select choose the model from here. So if I deploy this, I cannot deploy as I have no much more code about this. So that's all about today's presentation. And if I have any question or anything want to me,